Okay, this is the next recording for Algebra 1B. We are now still on Unit 1, but we are on Assignment 5. So you should have completed the first 3 assignments and taken your first quiz. This lesson is on the substitution method. The lesson starts out giving you some explanation of the substitution method. The objectives for this lesson are to solve a system of 2 linear equations by the substitution method, and to determine if an ordered pair is a solution of a system of 2 linear equations. There's a video for you to watch, which I strongly recommend you looking at. The first question asks you to select the best method of finding an accurate solution to a system of linear equations. Using algebraic methods is always the best method to solve any type of equation. The lesson then goes on to give you an example with a video of how to solve it. Again, I strongly suggest that you watch these because it's going to be very difficult to learn this if you do not read through and watch the videos for the lesson. As we begin, the assignment asks, for the following system, use the second equation to make a substitution for y in the first equation. So this method is a method in which you are taking what y equals and you are substituting it in for y in the other equation. So let me show you what that looks like. So our equations are 2x plus y is equal to 6 and y is equal to 3x plus 4. Our goal is to take what y equals and plug it in for y in the other equation. Because if this is what y equals, any y in the other equation can be replaced with it. So we're going to still write our 2x, but we're going to now take out the y, so we're not going to use this y anymore, and we're going to replace it with what y equals. So I basically have this first equation exactly the same. I still have the 2x, and I still have the equals 6. But this part, the y has been substituted, 3x plus 4. So you can see which one of those options looks like mine. They used parentheses, which is not necessary in this particular equation because we're not multiplying by anything, but you can see that 3x plus 4 replaced the y after the 2x and before the equals 6. This next question says, for the following system, use the second equation to make a substitution for x in the first equation. So this is the same concept. We're going to be taking what x equals and we're going to be replacing the x in this other equation with it. So my equations are x plus 5y minus 10 is equal to 0, and x is equal to 2y minus 8. So what they're asking is for you to take what this x equals and replace the x in the other equation with it. So instead of writing x, that x is going to get taken out, and I'm going to be putting in the 2y minus 8 in front of it. Then I'm going to write the rest of this equation exactly the same. So I'm going to say plus 5y minus 10 equals 0. Now here, you can see that there are some like terms that can be combined. What are they? 2y and 5y. They both have a y, so they're considered like terms. Both positive, 2y and 5y combined are going to give us 7y. We can also combine the negative 8 and the negative 10. Those are both numbers that don't have a variable on them. That's going to give us a negative 18. So we're looking for an equation that looks like that. And you can see which multiple choice answer makes the most sense. The next question says, solve the following system of equations by the substitution method. And they just want us to solve for y. So let's take a look at what that looks like. So first we need to analyze which variable do we have by itself. We have the x by itself, which means that we're going to be plugging that in for the x in this equation. So let's write out our 2 equations. We have 10x plus 10y is equal to 1, and x is equal to y minus 3. So we're going to start out by taking what x equals and plugging it in for the x in the other equation. So I'm still going to write the 10 at the beginning of the equation, but I'm not going to write this x anymore. This x is getting taken out, and we're replacing it with this. Now, 10 and x were next to each other, which means they were being multiplied. We want to keep 10 and our new value multiplied also. So I am going to put this in parentheses now. This shows that 10 is getting now multiplied by y minus 3 because 10 was getting multiplied by x, and this is what x equals. Then I'm going to write the rest of this equation exactly the same. Plus 10y is equal to 1. From there, I'm going to work on solving. So you know from solving equations that whenever we have parentheses, the first thing we need to do is to distribute. So 10 times y will give me 10y, and 10 times negative 3 will give me negative 30. Then I'll drop the rest of it down. Now I'm going to combine my like terms. I have a y here and a y here. 2 positive 10y's combined is going to give me a 20y. Then I'm going to drop down my minus 30 equals 1. Now I need to work on solving for y, which means I want to get the y by itself. I need to move the 30 and I need to move the 20. We know that from solving equations, we always move our adding or subtracting first. So I'm going to do the opposite of subtracting 30, and I'm going to add 30 to both sides, which will cancel that. And I'll get 20y is equal to 31. And then my last step is to divide by 20 so that I can finally get my y by itself. So I'm going to have y is equal to 31 over 20. And you can see which multiple choice answer makes the most sense there. The lesson then goes into substitution as rewriting equations and gives you some more explanation in another example. The next question says, for the following system, use the second equation to make a substitution for y in the first equation. So here, we don't have either variable by itself. What we're trying to do is we're trying to get the y by itself in the second equation so that we can plug it into the first equation. So let me go ahead and write my equations down. So if I want to plug this equation into this, I need to have y by itself so that I can put it in for this y. This y is not currently by itself. Why not? Well, because we have the 4 on the same side of the equal sign. So if I can move that 4 over, that means the y will be by itself, which means I'll be able to plug in my value in for that y. So how do I get rid of that 4? Well, because 4 is being added to y, I can subtract on both sides, which cancels it out, leaving my y by itself. Now, can I subtract 4 from 5x? No, I cannot. Why not? Well, the 5 has an x on it and the 4 doesn't. They're not like terms. So my only option is just to rewrite it 5x minus 4 and drop it down. Now I have y by itself, which means that I can now take what y is equal to and plug it into this equation up here. So this says 3x, and now instead of y, remember I'm taking y out and I'm replacing it with what y equals, which is 5x minus 4. And then it's still going to equal 1. So I still took this exact same equation, I took the y out and I replaced it with this. And you can see which multiple choice answer makes the most sense there. The next question says, for the following system, use the second equation to make a substitution for x in the first equation. So this is the exact same thing we just did. However, this time they want us to get x by itself in this equation instead of y. So let me go ahead and write down my equations. So here's my first equation that I'll be substituting into. And here's the equation that they would like me to get the x by itself for. So in order for me to get x by itself so that I can plug that value into this x, I need to get rid of two things. I need to get rid of the y, and I need to get rid of the 3. It really doesn't matter which one first. I'm going to get rid of the 3 first. So I'm going to go ahead and move my 3 over by subtracting it. It will cancel here, and over here I'll have 0 minus 3. So my equation will now look like this. X minus y is equal to negative 3, because 0 minus 3 is negative 3. Now I'm still trying to work on getting the x by itself, which means I still have to move the y over. How would I do that? Well, because y is being subtracted, I'll add it. Okay, which is going to give me now my x by itself. And then I'll have y plus negative 3. Or we could just write x is equal to y minus 3. So now that I have my x by itself and I know what x equals, I can go ahead and plug it in up here for this x in this equation. So let me get some clean paper so we can see what we're doing. So remember, the equation that we're trying to plug into is 3x plus 2y is equal to 7. And we got the x by itself just now. And we now know that x is equal to y minus 3. So I can now take my y minus 3 and I can plug it in for the x in this other equation. So I'm taking this and I'm replacing the x with it because that's what this x is equal to. So I'm still going to write my 3, but remember I'm taking the x out and I'm replacing it with this. Now 3 and x were being multiplied. I know that because they were squished together. So 3 now has to multiply this. So again, this is going to go into parentheses. And then I'm going to write the rest of the equation exactly the same. So I just copied down my 2y and my equals 7. And you can see which multiple choice answer looks the most like that. The next question says, which of the following would not be the result of a substitution in the following system? So there's a couple different options we have. It looks like here we have 7 minus 2x minus x equals 1. We have 2x plus x plus 1 equals 7. And we have 2y plus 1 equals 7. So this is going to involve us needing to figure out what it would look like if we substituted for y and what it would look like if we substituted for x. So we're going to actually have kind of two panels of work here. So I'll split these up into two sides. So we're going to take the same equations, 2x plus y equals 7 and y minus x equals 1. And we're going to do it two ways. We're going to do once we're substituting for y and once substituting for x. Let's substitute for y first. So if I want to substitute for y, that means that this y in this equation has to be by itself in order for me to substitute it up here for y. How do we do that? Well, we take our equation and we move over our x so that y can be by itself. So I'm going to do that by adding x to both sides. So this is going to give me y is equal to x plus 1. Now that we know that y is equal to x plus 1, we can plug it in for this y up here, which would look like this, 2x plus, and instead of plus the y, we'll take that y out and we'll put in x plus 1 and we'll equal it to 7. So we have 2x plus x plus 1 equals 7. Now you can see on our multiple choice, that is one of the options. 2x plus x plus 1 equals 7. So this option right here is not going to be the one that's not going to work. So that one we don't want to select. Now let's see what happens if we go ahead and substitute for y. So this time, instead of getting the y by itself, we want to get the x by itself. So the way to do that would be to get rid of the y. Now, because this x has a negative in front of it, it might be easier for us just to switch our x and our 1 to get the x by itself. So what I mean by that is let's add x to both sides, which will cancel it here. And then let's move that 1 over so that x can be by itself. So I'm going to subtract the 1 from both sides. So I'll have y minus 1 is equal to x. Now my x is by itself, and I know it's equal to this. So this can get plugged into the x in this original equation. So I'm going to have 2, and then I'm going to take out that x. I'm going to put my y minus 1. And then I'm still going to keep my plus y is equal to 7. So we have 2 parentheses y minus 1 plus y equals 7. And you can see that that's an option here. 2 parentheses y minus plus 1 is equal to y equals 7. So we're going to go ahead and choose this one as the one that is not the result of a substitution. This wants you to actually solve the following system of equations by the substitution method. So let's go ahead and write out our equations. So we have 8x is equal to 2y plus 5, and 3x is equal to y plus 7. Now, before we do any substituting, we need to figure out how to get a y by itself or an x by itself. I would say that getting this y by itself is probably going to be the simplest way to attack this. So I'm just going to move this 7 over by subtracting it on both sides. That's going to give me y is equal to 3x minus 7. Because the 7 is gone, I just put my y here, and then I have my 3x minus 7. Now I'm going to take this 3x minus 7, and I'm going to plug it in for this y up here, because this is what y equals. So my equation is going to be 8x is equal to 2 times 3x minus 7 plus 5. And I'm going to solve it just like a regular equation for x. So the first thing I'm going to do is I'm going to distribute. I'll get 8x equals 6x minus 14 plus 5. I'll combine my like terms. So I'll get 8x is equal to 6x minus 9. I'll go ahead and move over my x so I can get all my x's on the same side. And I'll get 2x is equal to negative 9. And then I'll divide by 2. So it looks like my x value is negative 9 over 2. Let's go ahead and look at our multiple choice options and see which one of those makes the most sense. So I see I have 2 options that have negative 9 over 2. This one is in the x spot. This one is in the y spot. We know that ours is an x value, so we want to choose the one that has the x value of negative 9 over 2. This one is another one asking us to solve the following system of equations. So let's go ahead and write our equations out. It's going to be 2x plus y is equal to 3, and x is equal to 2y minus 1. So I'm going to go ahead and plug in this for my x value because I have this x by itself. So it's going to be 2, and instead of x, remember I'm taking x out, and I'm plugging in my 2y minus 1. plus y is equal to 3. So I'm going to go ahead and distribute, which is going to give me 4y minus 2 plus y is equal to 3. I'm going to combine my like terms. 4y and y will give me 5y minus 2 is equal to 3. I'm going to add my 2 to both sides, and I'll get 5y is equal to 5. And I'll divide both sides by 5, and I'll get y is equal to 1. Now, to get a solution set, we need an ordered pair. So we don't just need a y value, we also need an x value. So right now, we have half of our answer. We have our y value, but we still need to figure out what our x value is. The way we're going to do that is we're going to take this y value that we found, we're going to go back to one of the original equations, and we're going to plug that y value in. So I'm going to take 1, and I'm either going to choose this equation or this equation, and I'm going to plug it in for y. Let's go ahead and look at the second one. X is equal to 2y minus 1. Now, I just figured out that y is equal to 1, right? So what that means is I can take that 1 and I can plug it in for this y. So I'm just basically rewriting one of those original equations and putting in 1 for my y value. Remember, we got that 1 from our problem solving over here. So now I'm doing 2 times 1, which is going to be 2, and 2 minus 1, which is going to be 1. So x is also 1. So our ordered pair would be 1, 1. So what I'm going to go ahead and type in over here is just going to be 1, comma, 1. The next one says solve the following system of equations. So again, we can see that we have 2 equations and we do have one that has an x by itself. So if I go ahead and write this out, I'll have 3x plus 2y minus 5 is equal to 0. And then I have x is equal to y plus 10. Because we have this x by itself, I can take what this equals and plug it in for this x. So I'm going to rewrite it 3 times y plus 10 plus 2y minus 5 is equal to 0. And I'm going to solve from there. So first I'm going to distribute. That'll give me 3y plus 30 plus 2y minus 5 equals 0. Then I'm going to combine my like terms. 3y and 2y will give me 5y. And 30 and negative 5 will give me 25. Now I need to work on getting the y by itself. So that means I need to move my 25 over and I need to move my 5 over. We know that we're going to move our 25 first because it's being added or subtracted. So I'll have 5y is equal to negative 25. Remember that 0 minus 25 just gives us a negative 25. Now I'll go ahead and divide. And I get a negative 5 for y. So just like the other one, we have to get both, right? Remember that our answers as ordered pairs should have x and y. So we have our y value, which is negative 5, but we now need to find our x value. We'll do that the same way we did the last problem. We'll take our negative 5 and we'll either put it in for this y here in this equation or this y here in this equation to get what x equals. I think it probably looks easier to put it in this one. So if my equation is x is equal to y plus 10, and I know that y is equal to negative 5, I'm just going to put a negative 5 here for this y. So I say x is equal to negative 5 plus 10. Well, negative 5 plus 10 is going to give me a positive 5. So my answer should be 5, negative 5. And the way you type that in is just to say 5, comma, negative 5. The next problem says, Shauna and Kai both work the same pet store. On Monday, Shauna counts 52 birds and cats in the store. For the same animals, Kai counts 138 legs. How many birds and how many cats are in the pet store? So this problem is going to require us to set up a system. We're going to use birds and cats as X and Y. We're going to let Y or X equal the total number of birds in the pet store and Y equal the total number of cats in the pet store. We know that altogether we have 52 of the both. So our first equation is going to look like all of our birds plus all of our cats equals to 52 total. Then they said that the total number of legs was 138. Well, birds have how many legs? 2. Very good. And cats have how many legs? 4. That's right. So if birds are X, they have 2 legs. If cats are Y, they have 4 legs. And all together, they said there were 138 legs. So that's going to be our system of equations that we're going to use to go ahead and solve this problem. Now, I need to decide whether I'm going to solve for X or Y first. I could very easily take my X over or my Y over and then plug in. I'm going to go ahead and get X by itself by moving my Y over, which means I'm going to go ahead and take my equation and subtract Y from both sides to go ahead and solve it. Now I can take this X value and plug it in for the X in the other equation to help me solve my problem. So I've got 2, and now I'm going to plug in my Y value, 52 minus, or my X value, I'm sorry, minus Y. Then I'm going to write down the rest of my equation. First, I'm going to distribute. So this is going to be 104 minus 2Y plus 4Y is equal to 138. Then I'm going to combine my like terms. Negative 2Y and 4Y is going to give me a positive 2Y. Then I'm going to move this over by subtracting. So I'm subtracting 104 from both sides. So I have 2Y is equal to 34. And then I'm going to divide by 2, and Y is 17. So remember, Y is the number of cats, which means I have 17 cats. Now, if I had 52 all together, and 17 of them are cats, we just need to do 52 minus 17 to figure out how many birds, okay? So that means that we're gonna have 35 birds. So my X value is 35, and that is the number of birds. So when I go ahead and type my answer in here, you're gonna say that there are 35 birds and 17 cats. This is a word problem for you to type in a paragraph. I'm going to go ahead and allow you guys to skip this problem since this has already been pretty long. From here, there's a video on the comparison method. I encourage you to watch it and look through it. The comparison method, this says which of the following equations could be the result of using the comparison method. So it says solve each equation for X. So get your X by itself for both equations. Once you look at your comparison, you can see that 6 minus 2y is not the same as 2y minus 6, but 8 plus 4y is the same as 4y plus 8, which will help you choose your correct answer. And the rest of the problems in this assignment are the same, except for the last one that is asking you to solve this using the comparison method. If you have any questions or concerns, reach out to me and we can work together.